So welcome back to my channel. In this video, I'm going to take you through augmented matrices. So we are about to start a system of equations course, and before we go into that course, we need to know augmented matrices, right? Yep. So what are augmented matrices? So once you hear matrices, you know that a matrix is just rectangular array of numbers, right? So you have a rectangular shaped bracket like this, and you have some entries, let's say A, B, C, D, right? So that is matrix. So when you say augmented matrices, it is only associated with systems of equations. System of equations, right? So right now, when you say augmented matrices, it's simply a matrix, right? Whose entries, that is row wise, is the constant associated with a particular equation. So assuming that I have an equation, let's say 2x1 plus 3x2 minus x3 is equal to 1, right? So to find augmented matrix, it's only the coefficients of the constants within this equation that will give me one of the rows of this augmented matrix. So here you can see that the first coefficient is 2. You just write 2 here. Then the next one is 3, followed by the coefficient of x3, which is negative 1, right? But there's one thing about augmented matrices. You realize that our values on the right hand side, that is behind the coefficient and the equal sign, right? You place it here. So you can introduce a bar here to separate our coefficient matrix, which is directly the coefficient of our variables. Then the one here is signifying our B, or let's say the solution to the system, right? So this whole thing should combine to give us 1. So you introduce your bar, then you put 1. So I can write a series of equations. Let's say 4x2 minus, let's say 5x3 is equal to 6. So this is another equation, and I can add this to this to give me 0, because the coefficient of x1 is 0, right? We don't have any x1 term here. So I simply put 4 here. I put negative 5, then let's say 6, right? Yeah, so I can add last equation. Let's say 3x1 minus x2 plus 2x3 is equal to 0. So I will just write my 3, negative 1, 2. Then I'll put 0 here, right? So this is just how to represent a system of equations. So combining this equation 1, equation 2, then equation 3, we call these three systems of equations, right? So any system of equations can be represented as an augmented matrix in this form. So that's the concept of augmented matrix. Now let's take a nice problem here to solve. Under augmented matrices, we have what we call row operations. Row operations. So we can perform some row operations in order for us to solve these systems of equation here. So let's see. So let me give you an augmented matrix here. So for the following augmented matrix, right? For the following augmented matrix, perform the indicated elementary row operations. So now let me give you the augmented matrix I have here. It's simply 4, negative 1, 3, then you bring 5 here. 0, 2, 5, 9. Then I have negative 6, 1, negative 3, 10, right? So this the augmented matrix given. So let's perform this. So the first row operation is 8R1. B is giving us R2 implying R3, then C is R2 plus 3R1 switching with R2. So let's take the first one. How do we solve this problem? So when you say row operations, it's simply manipulating what? The row. So it's mainly addition, subtraction, you get it? So you manipulating the rows of a matrix. So the first one is saying we should find 8R1, right? So 8R1 means that R1 here signifies row 1. So I can map here as row 1. So R1, this place becomes R2, this place becomes R3, right? So if they say 8R1, it means that you rewrite everything and write 4. So it's 8 times row 1. So 4 times 8 will give me what? 32, right? So 4 8 is giving me 32. Then 8 times -1, -8. 8 by 3 is 24. Then don't leave this out. It's also included. 8 by 5 is giving me 40, right? So you just add the rest of the entries and you are done for this row operation. So this is how we perform a simple scalar multiplication as a row operation. Then let's see how we do the second one. R2 switching to R3, right? So R2 switching to R3. Whenever you see this symbol as a row operation, all that it means is we should just interchange the position of R2 and R3. So we realize that this is our R2, this is our R3. We only interchange their position. So I'll simply have 4, -1, 3. I'll have 5, right? Then my R2 now becomes my R3. So I'll start with -6, 1, -3, 10. Then I'll have 0, 2, 5, 9. So this gives us our second row operation. Then finally, we are going to do this C. The C part is we are adding row 2 to 3 times row 1. Then after we will map it to row 2, right? So let's see how we do that. So we are going to first do the initial manipulation, that is R2 plus 3 times R1, R2 times 3 times R1. So how do you do this? You simply take your row, so you write this R2 plus 3 times R1. What will it be? Our R2, the first entry is 0. 0 plus 3 times my R1, which is 4. That will give me what? 12, right? So you have 12, comma. Then the second part, you have 3 times R2 plus 3 times this. So R2, which is 2, plus 3 times -1, right? So -3 plus 2, you get -1. Then the third one will be 5 plus 3 times this. So 5 plus 3 times 3, 9, 14, right? Yeah, 14. So now you realize that this whole thing is giving us these entries 12, -1, then 14, right? So what this is saying is after this manipulation, this whole thing is moving to row 2. This is not switching. You realize that the switching, you can see this. Row 2 will go to row 3, then row 3 goes back to row 2. But in this case, it's implication. Everything here maps to row 2. So everything will remain as it is. Then I'll have my, so I'll have 4, -1, 3, 5. Then my row 2, which is giving us 12, -1, 14. Then I forgot here, 9 plus 3 times 15, 24, right? Then the last part is -6, 1, -3, then 10, like this. So as simple as that. As simple as that. Thank you for joining me in this video. Hope seeing you in our next tutorial where we'll be tackling how to solve the systems of equation using the Gaussian elimination method. Please don't forget to subscribe, you like, and you share.